Hello and welcome to yet another South Korean College Scholastic Ability Test video, which is the test that South Korean high school seniors take in order to apply for the college. Today I got this really long and boring looking problem, which is actually quite interesting and challenging. So let us read the problem. A fully automated lathe manufacturing plant produces two types of lathe called alpha and beta. Two types of machines, A and B, are used for the production of these lathes. Due to maintenance, machine A cannot be operated more than 18 hours per day, and machine B cannot be operated more than 20 hours per day. Moreover, to produce one lathe alpha, machine A must be used for 3 hours and machine B for 5 hours. And to produce one lathe beta, machine A must be used for 6 hours and machine B for 5 hours. The selling price per lathe is 2 million Korean won for alpha and 3 million Korean won for beta. Assuming that the lathes produced are sold immediately, what is the maximum daily sales revenue? So that was the entirety of this long problem. And we also have this table, which summarizes the conditions given in the problem. I recommend you to pause and take enough time to fully understand the problem and this table before proceeding to solution. Alright, now I will present you the solution. In the given situation, the changing variables are the number of each type of lathe produced. So let's assume the situation where we produce X units of lathe alpha and Y units of lathe beta. If we write the given conditions as mathematical expressions, we can obtain several linear inequalities. First of all, the number of lathe produced cannot be negative, hence both X and Y must be greater than or equal to 0. And I will call this first inequality. Next, the main constraint we have is this machine operating time limit. Let us consider machine A first. To produce X alphas, machine A must be used for 3X hours, and to produce Y betas, machine A must be used for 6Y hours. The total operating time of machine A cannot exceed 18 hours, so we have 3x plus 6y must be less than or equal to 18. Let us write this as the equation of line form, which is that y must be less than negative 1/2 x plus 3. Let's call this inequality 2. This form will be useful later when we think about graphical representation. As for machine B, it is used for 5x hours to produce alphas and 5y hours to produce betas, and since the limit is 20 hours, we have 5x plus 5y is less than or equal to 20. Which can be simplified to y is less than minus x plus 4. And this is the inequality number 3. So x and y can only have values that satisfy all of these three inequalities. These values of x and y can be represented as the region on the xy plane, the shaded region shown in the figure. The first quadrant, under the line y equals minus 1 over 2x plus 3, under the line y equals minus x plus 4, including boundaries, because we also have equality here. Now let's think about sales revenue. Let us denote the sales revenue from selling the lathes as R in the unit of million Korean won. Then from these prices, R is given as 2x plus 3y million Korean won. We can write this in the equation of line form, which is y equals negative 2/3 x plus r over 3. This is the straight line with slope negative 2/3 and y-intercept r over 3. That is, as values of x and y change within the region we obtained, if we draw a line with slope negative 2/3 passing through point x, y, its y-intercept will be 1/3 of the total sales revenue. In this problem, we want to find the maximum value of r, so when does this r becomes maximum? Well, you can easily find out that the y-intercept becomes maximum when the red line y equals negative 2/3 x plus r over 3 passes through the intersection point between two lines y equals negative 1/2 x plus 3 and y equals minus x plus 4, which is 2, 2. So this is the case where the revenue r becomes maximum. Therefore, using the values x equals 2 and y equals 2, the maximum revenue is 2 times 2 plus 3 times 2, which gives 10 million Korean won. Therefore, choice 2 is the correct answer. FYI, this particular type of problems is called linear programming. It was extensively researched and developed during World War II for efficient maintenance and transport of military supplies, and nowadays it is firmly established as a mathematical branch and applied to many fields including statistics and administration. And that's all for today's video. Thank you all for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.